investigating the impact of inquiry-based teaching on science learning in Italy, together with my supervisor, Andrews, sitting here. So just something funny to share. Before the presentation, I was kind of nervous, so I kind of Googled how to deal with speaking nervous. And Google came up with like a show up survey, kind of sometimes it do pop-ups. And it kind of asked me to scale my nervous and say how nervous you are. And my nervous level is that I'm too nervous to fill in the survey. Google, you are no use. And it's kind of funny after I did that, but it's just the justification of why it gives you a survey is that it asks you to scale the level of your nervousness, and then it can give you better answers for some kind of website. So it kind of cuts your nervousness into like two different parts and give you different interventions. And if you are not that high level of nervous, they're just going to say it's fine. It means you're here. It's okay. And so this is not just to show a funny story. It's more like a reflection about we are trying to scare everything, and we are trying to scare everything, and we are trying to get very close to the real measure. And we do that by asking how often do you do that. We ask about different levels of things, about the frequency of things, and then we use them as continuous variables and use that to try to measure things and do different level of analysis. But when we think about that, it's actually in real life, like the nervousness. In the real life, they ask you to cut into pieces of different levels, and then they would have different interventions. So this is a switch back to my research. If we think about how we used to, or how we are measuring the teaching practices or teaching quality, that we can relate to the same. We are asking for the frequency, and we are asking for how often things happen in the classroom, and we take for granted to think this is the teaching quality we are measuring. So that is the setter stone. Let's go to the introduction part. And for my research, I'm looking at the inquiry-based teaching and the impact for the student's science achievement. Inquiry-based teaching is a very promising approach to help students develop the reasoning abilities. And the approach encourages students to ask questions, to have experiments, gather evidence, and draw conclusions. And we can see inquiry-based teaching based on some scientific method, it has been shown that it could help students to learn. And the researchers has been using empirical study to see what is the relationship between the inquiry-based teaching and science achievement. And there hasn't been a conclusion or summarize the result. There are some researchers saying that if we have a higher level of inquiry-based teaching, the students might get better science outcomes. And also some recent studies using large-scale assessment have been showing there might be a negative relationship between those two variables. And one explanation we can find, this will link back to my nervous story, is that it's the explanation about different results of such relationship could, because of how we measure teaching quality in different ways and how we use those measurement models in our analysis. So, in other words, if I describe a classroom to you and we are facing a science teacher and a bunch of students, and if the teacher was using some kind of learning activities or science instructions belong to inquiry-based teaching, and if we have a certain amount of such learning activities, we will think, okay, the student might be beneficial from those learning activities and they might gain their academic outcomes. But if we think, but those learning activities actually demand a substantial amount of time, and time and energy are very limited in one classroom. So we can think that if the teacher has accessed the overperformed on those activities, or the teacher are only focusing on those activities, the student don't get other instructions, or the student don't get opportunities to have other activities, then we could relate that somehow they find negative relationship is that it's too much for students. So from that logic, we can think about maybe there is a non-linear relationship between inquiry-based teaching and science achievement. And that is the starting point of my research. And following that, we find one kind of outstanding research is from Teague and I think from Nielsen and Teague, I hope I remember their full name, but I don't, from the University of Norway, and they had a paper that they start to bring an idea of curved linear relationship, which is actually saying that starting from not zero, but starting from having a substantial amount of learning activity belongs to inquiry-based teaching is good, and then it would reach to an optimum value, and after that the relationship dropped down really fast. And they find significant curved linear relationship. They call that curved linear relationship in their study, and they find significant curved linear relationship by using the team's 2015 in Norway data. So my study is to extend their study and trying to see, as their study kind of leaves a question on, okay, we started to look at the curved linear relationship, but it leaves the door open on, does it exist in other countries or educational systems? So my research is jump into that open question and trying to see whether we can find similar linear or curved linear relationship, or it just happened for different countries. When I submitted my abstract, I actually thought I could do that with all the countries, but based on the team's sample selection, so just to maybe, I don't know if people are knowing teams sampling strategies, that they normally select the school first, and then they select the classes. And if you ask how you select the teacher, they actually don't select the teachers, they just to select the classroom, and they give the teacher surveys to those teachers who belongs to those selected classrooms, which kind of brings out two issues. First is that if you think in that way, the teachers are not representative of the population in one particular education system or country. And then also the teacher weight provided by teams are not like the representative teacher weight. They're not proper teacher weight for analysis. And another issue is that it brings out a lot of many-to-many cases. Like one teacher can teach multiple classrooms. And also one classroom can have many teachers. So it's kind of messy. You don't get representative sample sizes, and it's a lot of many-to-many cases. Maybe we should drop this, and that will be end of my presentation, but it's not. So what I am going for a solution is that I'm going to only focus on the one-to-one cases, which means that in some countries, they would have the 4 cases of one classroom, we only get one teacher. So by looking in this perspective, it's not talking about the teachers, how teacher performs, it's actually the one teacher is represented for the quality of the inquiry-based teaching in this classroom. So in that sense, we get to use the classroom weight, it will make sense, and we can find like reasonable samples. So why we choose Italy? So we in the end just did the analysis with Italy. The reason we choose Italy is that Italy is not the only one. I forgot Turkey down there, but they're like the only 2 European countries that actually had the sample design with one teacher, one classroom. So it's more straightforward to establish a link between teacher and student. So we had our main focus on the relationship between linear and curved linear relationship between inquiry-based teaching and science achievement, and we focus on Italy. And in addition, I'm bringing the differential effectiveness perspective under different constructor factors as SES. And as the teams in 2015, because by the time I'm reading the paper, we already have teams in 2019. So I figured out that the teams 2019 and the 2015 data, both of them with the Italy data fit the same criteria. So I'm going to perform the study with both data sets and trying to compare them to bring a broader view across time. So for the study, we have 3 objectives. So the first is to test the linear and curved linear relationship. And the second is to bring the differential effectiveness perspective and examine the interaction between the socio-economic status and inquiry-based teaching in predicting student achievement. And the last one is just to compare whether the tested model might be different from the data provided with 2015 and data provided by the 2019. So the methodology, we have the data, and I have put my sample sizes here. As you can see, we have relatively large sample sizes for students. We got around 4,000, 3,000 for across the year, but the teacher sample sizes or the classroom sample sizes aren't as big as we are expecting. And for the measures, the first is using the inquiry-based teaching by following 5 items, starting from design or plan experiment, conduct experiment, present data, interpret data, and use evidence. And then we use the socio-economic status from more like common sense, 3 choices, numbers of book, and educational level of both parents. And we are using the 5 classical value and get the imputed result. So, for the data analysis plan, we have 2 steps. The first step is the measurement model. So first, we are trying to construct the measurement model using the multi-level confounding factor analysis. And the second step is to have about 5 multi-level structural equation modelings to compare whether the linear or curved linear would exist. So this is how the model looks like. It's pretty straightforward. Oh, sorry. I forgot to mention that we also did the multi-level confounding factor analysis for the double latent model for the socio-economic status. But as you can see, if we have 3 variables, the model fit is going to be good anyway, so I didn't show to save the time. And let's have a look at the result from the MCFA first. We kind of have like 4 sub-models. So the first one is just the original model following this figure, and we didn't put any variance between items. It's not really a good model. It's a poor model fit for both years. So I decided to put some variance between the items, and I have several goals following the suggestions by the M+ result. And so you can see the remaining 3 sub-CFA was having 1 variance, another variance, and 2. And it turns out that the second choices would be better. So when we try to put covariance between design the experiment and conduct the experiment, the model looks better. And how better is like this. So this is the model fit showing for 2015 and 2019. And if we look at that RMSEA, I'm not happy with the result. But if we look at CFI or SRMR, it's like okay-ish. Yeah, I hope people don't get too harsh on this part. And yeah, it's the obvious. But then it's a factor audience. I'm just going to jump on this because it's not really interesting. Then we have our focus analysis on the MSEM. So I think it's more obvious if we show by the figure. This figure is not produced by me, it's produced in Tiga's paper. I'm trying to follow up all the models they have done. So if we can do a comparison between this and the Norway data. And I actually want to stand because it's easier to see. So as you can see, we have like 2 sets of data, 2 sets of models. For the models in the right side, this is the linear relationship. And starting with model 1.1, that we are looking at straightforward how inquiry-based teaching direct to the achievement. And then we put the SES as control. For the second model, we call them 1.2. And then we put the interaction for our second research question to look at the interaction between the inquiry-based teaching and the socio-economic status. And then by the other side, or the left, by the left side, what you see different is that for each model in the left side, for this set of model, we included a quadratic term. It's called inquiry-based teaching times inquiry-based teaching. So starting with the model 2.1, we are just adding one more inquiry-based teaching, and in this still the control. And the last is crazy complex interactions for 3 inquiry-based teaching times inquiry-based teaching times socio-economic status. And to mention, we didn't get to do that. I mean, I tried really hard, but the machine kind of don't allow me to do that. And as I checked from different literature, it seems out based on what people answer in ResearchGate, is that sometimes when you have like 3-dimension interactions, you need larger sample sizes to perform such complex analysis. So I just dodged that one. Okay, now I can move back. So those are the models to follow the research questions. This, we are going for the result session. So what we can see from the result, okay, I can show like this. So we are starting looking at the model fit. It was at the bottom. The model fit shows if we compare the model from 1.1 to 2.1, that we can look at the AIC and the BIC, and you can actually see this doesn't really change much, which also kind of means when we added the curvilinear term, the counteractive term, the model didn't really get better. I didn't use like the likelihood ratio test. I just simply by looking at the model fit indices to check how better the model gets. And we start to checking the AIC and the BIC, and from model 1.1 and sorry. If we look at here and here, you can notice that the model from the model indices, it didn't really get much better. And the same from the 1.2 and the 2.2. If you look at the number here and the number here, it didn't really increase much based on the model fit. And then we move to our research questions. For the first research question, we look at the linear and curvilinear, and it kind of goes with some of the research to say we got negative relationship. It just, I didn't get significance. I kind of envy everyone about significance results now. Like, you don't see lots of significant result here, and we can see this is negative, but for both linear and curvilinear, it's not significant. And then we added the control, that we can see that this is the classroom socioeconomic status, and the classroom socioeconomic status significantly positively impact the science achievement. I mean, this is not one of my focus, but this is my only significance, so I have to say that. And then we see the interactions, and follow with, we still don't get significant interactions between the inquiry-based teaching and the SES. And move to the next page. The results are kind of similar in the way of starting with the comparison of the model fits, and the model fits didn't really change much, and then we also didn't find the linear or curvilinear relationship, and there are no interactions. But what is consistent is that the classroom socioeconomic status has been positively predicted the classroom average science achievement. So I hope it's not disappointing results. I mean, non-significant is still good. This is what I keep telling myself. So I think the discussion might be more interesting, although we didn't find any linear or curvilinear relationship tested for both years. But like consider the sample sizes we had. If you remember, we had like 230 classrooms for 2015, and we have 209 for 2019. And based on the sample sizes we had, the sample sizes is kind of small for multi-level analysis. So this is kind of understandable to have non-significant, as its lack of certain statistical power. And at the same time, if we look at the variation of the frequency of inquiry-based activity, it's kind of minimum. So it's also limited the statistical power in that way. And one of my plan to fix this issue a little bit is, as I have like the table of all the countries or educational systems with the one-to-one cases. So I think what I could do, not for future research, maybe for tomorrow, is just to combine all the data sets that only has one-to-one cases, and then perform the analysis again. And in that sense, I would have much more classrooms. And also, we didn't find any indications for students from like there are no indications students from high or low socioeconomic classrooms is gonna experience different benefits from the inquiry-based teaching. So there's no interaction. Not sure how to interpret that, so I'm just gonna say there's no interaction. And the last is our only significant result is the socio-economic status of the classroom. It showed like a significant relationship with the achievement in both models, which kind of accounting for the majority of variance in the outcome variable. So that is the end of my presentation. I'm also looking for like collaborator if anyone finds that interesting to write a paper with.